Hello everyone and welcome back to Lifey Technologies YouTube channel. I hope you're doing well and thank you so much for watching this session. This is part 66 of our Huawei Lab Simulation series. And remember that in this series, we demonstrate to you how to configure, implement and troubleshoot different networking protocols or different networking technologies on Huawei routing devices. So if you are learning how to configure, operate and manage Huawei devices, kindly check out the previous episodes on this series. And if you have any question, always feel free to reach out and we will be glad to help you clarify or fix the challenges that you are facing when you are doing these lab simulations. Again, just a reminder that if you are watching this episode and you are yet to subscribe to our channel, kindly support this channel by subscribing to it. Also remember to like, comment and share this video with your connections. So in this session, we will be discussing how to implement route tagging with BGP Community Attributes on Huawei devices. We know that BGP has so many path attributes and BGP Community is just one of the attributes. This is an optional transitive BGP path attribute. Transitive in a way that it can be propagated from one autonomous system number to another autonomous system number. So with BGP Community Attribute, we are able to tag the routes. Remember that BGP handles many routes and sometimes you want to control how the export and import of routes is happening. You want to change some attributes. You want to change some parameters of the routing information that is exchanged between different autonomous systems. So what you can do is you can tag these routes in one of the autonomous system number and then you are able to identify these routes across different autonomous system numbers. So you are able to apply policies to these routes. You are able to filter routes. You are able to do some changes on these routes that have been tagged with the communities. So this is what we'll be demonstrating in this session just to help you understand how you can configure route tagging using BGP Community Attributes on Huawei devices. This is the topology that we'll be using. We have 3 autonomous system numbers. We have a 65100 which has router R1 and this is where we'll be applying the route tagging. So we have these prefixes that are on R1 and we will be advertising these prefixes to the other autonomous system numbers. And when we are advertising these routes, we will be tagging them with a community attribute so that we are able to identify these routes across the entire network, even in the different autonomous system numbers. And then on R2, we'll be able to verify that these routes are coming in with the communities, with the correct community that we've added on the routes on R1. And that will be the objective of this lab. So you have R1 in a 65100. You have R2, which is a 65300. You also have R3 in a 65200. You see that we've assigned some point-to-point IP addresses. And as usual, we need to start by doing the basic configurations. We need to configure the point-to-point IPs. We need to configure the host name. And once we've completed the basic configuration, we can now go ahead and configure the BGP peering session between R1 and R2, R2 and R3. And once we've done that BGP peering configuration, we can now go ahead and verify that the routes are not having any tags, they are not having any communities, and we go ahead to the final stage where we'll now be adding the communities on the first 2 routes. So we only add route tagging on the first 2 routes. The rest will be left to untagged. So we'll not be adding any communities on 192.168.2.0 or 192.168.3.0. And then later in the subsequent session, we will show you how you can use this tagging to filter the routes on R2 and even how to use the common BGP community attributes. So the first step, again, we have the topology setup in ENSP. This is the topology. as we've discussed, R1, R2, R3. And I've mentioned that the first step that we need to do is to do the basic configuration. We need to configure the host name. We need to configure the interface parameters. So we need to configure the IP addresses, and we are creating loopback 0, 1, 2, 3 on R1, and these are the network that will be advertised to BGP, and then we will demonstrate how you can do tagging on these routes that have been propagated to BGP. So on R2, we also need to do the same. On R2, we configure the interface IP addresses for the back-to-back connection to R1 and R3. And then on R3, we also do the same. We configure an IP address on the interface towards R2. So let's start by doing these basic configurations. So we start by R1. So this is R1. I'll do the configurations. Once you've applied the configuration, we can display IP interface brief. You will see that we have the point-to-point interface between R1 and R2. We also have the loopback interfaces configured 0, 1, 2, 3. So that is it for R1. On R2, we do the same. We configure the interface parameters. So I'll apply this configuration. I can verify by running display IP interface brief. You see that we have the point-to-point between R1 and R2, R2 and R3. Finally, we need to do the configurations on R3. So I log into R3 and apply the basic configs. Display IP interface brief. So this is a very handy command that you need to master when you are checking the interface parameters. After I've done this, we need to configure the BGP peering session. So for BGP peering session, it's also very straightforward. We've already discussed about BGP basic configurations. On R1, we are configuring BGP 65100, and then we configure peering session towards R2, which is 10.10.10.1. We are just using the point-to-point IPs. Remember, this is eBGP, external BGP peering sessions. So we specify the correct AS number, which is 65300. This is for R2. And then we also need to advertise these networks into BGP so that they can be advertised so that they can be advertised to the neighboring peers. So starting with R1, this is the configuration that we need to apply on R1. So if you display this, you are able to see the configuration that we've run on this device. And then on R2, we also need to do the same. So on R2, we are configuring two BGP peering sessions towards R1 and R3. If you display these, we are also able to see the configs. Finally, on R4, on R3, we need to establish a peering session to R2. So on R3, I'll apply the configs. If I do display this, you see the configurations. We'll wait for the BGP peering sessions to come up. On R1, if I display BGP peer, you see that the session is established towards R1. On R2, display BGP peer. So one session is already established. We wait for the other session to come up. If it doesn't come up, then we'll troubleshoot. You see that the session has come up. So when the state is established, it means that the session has been established. It's fully up. Remember the BGP state machine. On R2, we can display BGP routing table. you see that we have this route. These routes have been propagated to BGP on R1. On R1, we also expect the same. Display BGP routing table. You see that we have all these routes advertised to BGP. On R2, we verify the same. On R3, I can display BGP routing table, and you will see that we have these routes available on R3. So on R2, if I want to check the different parameters that these routes are coming with, display BGP routing table, and I do 192.168.0.0, mask is 32, you will see that we have different parameters. For example, we have the BGP local router ID, the local S number, the path one available. It's coming from 10.10.10.0. We have the route duration, which is 1 minute 26 seconds. We have the original next hop. We also have the AS path. So the AS path is coming from 65.100. Origin is IGP. We have the made value, preferred value. Is it valid? Yes, it's valid. External, best, select, and many other BGP attributes that have been added on these routes. And this route has been advertised to such two peers. So it has been advertised to 10.10.10.0 and 10.10.10.3. So we don't see any community information because we haven't tagged these routes. But the good thing with tagging is if we are able to tag some routes, especially these routes that are coming from R1, we will be able to identify these routes on R2 based on the community attribute, and then we should go ahead and perform some route filtering or even change some parameters on R2 towards R3. So this is the third step that we need to perform. And for us to do this, first we need to identify the prefixes that we want to filter. So this is the first prefix, 192.168.0.0 and 192.168.1.0. So we configure these two prefixes, and then we can configure a route policy. In this route policy, we will call this IP prefix. So we have if match IP prefix tag 1, we want to apply this community. This is the format of a community. And then we need to bind this route policy on this BGP peer 10.10.10.1, and finally we need to advertise community. So this command will enable when we are advertising routes from R1 to R2, we need to add this community. We need to advertise the community attributes from R1 towards R2. So if we don't add this command, then the community attribute will not be propagated across the network. So we need to remember to add advertise community attribute. So this is on R1. I'll copy the configurations on R1. And then once I've applied it, if we go back to R2 and we run the same command, display BGP routing table, now you can see it will take some time. It will take some time for the community attributes to be propagated. You can see now that this route has a community attribute 65.100:100. So the community attribute has been added. And remember, you can go ahead and add multiple communities. You can have multiple communities added on the same route, and you can use them to achieve the objective that you are trying to achieve. So if I check the other route, .1, you also find that we have a community, but the one that we haven't tagged, .2, you will see that display BGP routing table 192.168.2.0. So this route, of course, it hasn't matched the policy, but what we want to do on R1, display this, you see the prefix. If I display current configuration, you'll see that we have the route policy. And remember, if you don't have any other statement after this policy, it means that everything else will be denied. And that's why you see that we don't have these two prefixes advertised to the peer, because they have been denied. So in the comment section, kindly let us know how we can fix this issue. How do we go about ensuring that this policy does not deny these two prefixes from being advertised to R2 and R3? Because even when you go to R2 now and display BGP routing table, you see that we only have two routes, but we still want to have all these routes propagated. Just that we only need these two to be tagged. The rest, the remaining two should not be tagged. And then we can process these routes on R2 as we want, or depending on the parameter that we want to change, or any other configuration that we want to do. We can filter the routes. We can do a lot using the community attribute that we've added. So in the comment section, kindly let us know how can we ensure that all these prefixes are advertised from R1 to R2. Only the first two will be tagged. This one we've already achieved it. We have tagged these two prefixes, but the remaining two should be advertised to R2 but should not be tagged. I hope you will be able to tell us in the comment section how we can meet this objective. And with these commands, we've demonstrated that if you display BGP routing table, you are able to see the community attribute on R2. We can also filter routes based on the community. So you can run display BGP routing table and you enter the community. So the community, of course, you need to specify the community. If you want to see only the specific route that are coming with a given community, you are able to see that these routes have this community. So they have the community 65.100:100. So I hope this is clear. I hope you've understood how you can perform route tagging on Huawei devices. Route tagging using BGP community attributes on Huawei devices. In the next session, we'll demonstrate how you can do the route filtering based on the community attributes. I hope this is clear. I hope you've enjoyed this session. Kindly remember to subscribe to our channel and also to check other training series on our channel. Thank you so much and see you in the next episode.